Lesson 5 is on reflections and vertical dilatations of the sine function. So this is also going to feel a little familiar, very similar to the quadratic equation. So a vertical stretch or compression, also called a change in amplitude. There's going to be an A value. So A is always going to be written, it's going to be right at the front of the equation. And that A value is going to tell you whether you have a stretch. So if there's a stretch, then the A value is going to be greater than 1. And if it's a compression, then the A value is going to be a fraction in between 0 and 1. As well, that A value, just like with quadratics, if there's a negative sign right after the equal sign and the A is negative, the function is going to be reflected across the x-axis. So we can flip this and reflect it upside down. We have a fraction in the front and it's negative. We would just have a compression of this function and a reflection across the x-axis. So let's just look at example 1. State the transformations for each sinusoidal function. So when we look at this equation, this fraction out front is telling us that there is a vertical compression of the sine function. The positive 3 means that this sine function is going to be translated 3 units up. This next function, we see a reflection in the x-axis because there's a negative right there. This is also vertically stretched because of the 3, so it's stretched by a factor of 3. We also have a horizontal translation of negative pi over 3, and we are also moving this vertically down. So example 2, we'll try our first vertical stretch here. So look at the function g of x equals 5 sine x. So what we know here is that there's a vertical stretch by a factor of 5. So this is even easier than it is with quadratics because all we need to do is multiply all of our y-coordinates by 5. So we know that, for example, if the y-coordinate is 0, it's still going to be 0. If a y-coordinate is 1, it would now become 5 because 1 times 5 is 5. So what I usually would do is graph our original sine function. So because we had to go up to 5, I didn't space it out as much as I usually do. So this would be positive 1 right here and negative 1, showing the amplitude for our root sine function here. So all I need to do now is look at my y values. This y value is 0. This y value is 1. If I multiply that by 5, it's going to be up here. If this y value is 0, it's still 0. 0 times 5 is 0. If this y value is negative 1, negative 1 times 5 is negative 5. And if this y value is 0, it's still going to be 0. And there we see a vertical stretch by a factor of 5. So state the amplitude, period, and equation of the horizontal axis. So the amplitude now, instead of just being 1 up to the maximum point from the horizontal axis, it's going to actually be 5. The period doesn't change. We are still completing one cycle in 360 degrees or 2 pi. The equation of the horizontal axis is still the same. The horizontal axis still runs through y equals 0. And the domain and range, the domain, as always, this will go on and on forever to the left and to the right. But our range now, it looks like our y values go vertically between negative 5 and up to positive 5. Example 3, graph the function g of x equals negative 1/4 sine x. So I'm able to space this out again, but what I would do is still graph my original root sine function first. But the reason I did that is because I noticed that we have a horizontal compression here of 1/4. So what that would mean is all of my y values get multiplied by 1/4. So I can also just divide by 4, but what I see here is that, first of all, imagine that this point 0, if I multiply that by 1/4, it's still 0. This point up here, if I multiply it by a quarter of 1 is only going to be up a quarter as high. 0 is still 0, and -1 times a quarter is just negative a quarter. So this is going to be very vertically compressed. So you can change the scale of your graph paper to kind of accommodate what you're trying to do. So in purple there, that would be compressed by 1/4. Now the last thing we have to look at is how do we reflect this in the x-axis? So a reflection means that this 0 stays at 0. It's just imagine this being a mirror along the x-axis. The point up here would actually be down here. 0 is still 0. This point here at 3 pi over 2 at negative a quarter would actually be up here at positive a quarter. So it's just the mirror image of what you see there, and that would be reflected in the x-axis. And finally, there's our function g of x equals negative a quarter sine x. State the amplitude, period, and equation of the horizontal axis. So the amplitude, it doesn't matter that it's reflected, we still have an amplitude of only 1/4. And the period is still 2 pi or 360 degrees. The horizontal axis, we haven't moved this vertically at all, so the horizontal axis is still y equals 0. The domain and range, the domain is the same. The range though, we're only going down to negative a quarter and up to positive a quarter. So the range is the set of y such that y is in between negative a quarter and positive a quarter, and y is an element of all real numbers. Okay, last example. This is pretty much everything that we're going to do with the sine function. So we have a stretch by a factor of 3. We have a horizontal translation to the right because it's in the opposite direction. Pi over 6 is the same thing as 30 degrees. And then we have a vertical translation up 2 units. So the first thing I'm going to do is just graph my original root function. Now I would imagine stretching this by a factor of 3. 1 times 3 is 3. 0 times 3 is 0. -1 times 3 is -3. And then back up to 2 pi. So there's our vertical stretch. We also need to move this up to +2. And we have to translate this function 30 degrees to the right. So the way we divided this up, 30 degrees is just 1 square. So imagine all of our points now, our key points are going to move 2 units up and 30 degrees to the right, or 1 square to the right. So this becomes our new point there. This point is going to move 2 units up and 30 degrees to the right. Here, we're going to go 2 units up and 30 degrees to the right. This one here down at -3 is going to go 2 units up and 30 degrees to the right. And here, 2 units up and 30 degrees to the right. What that +2 also means is that this becomes our horizontal axis at y equals 2. So there's our function, g of x equals 3 times x minus pi over 6 plus 2. State the amplitude, period, and equation of the horizontal axis. So the amplitude now, we're going from our new horizontal axis. Our amplitude is 3. Our period is still the same. We finish 1 full cycle in 2 pi or 360 degrees, even if it is translated to the right. And our horizontal axis now is y equals 2. The domain is still the same, but the range now, our final graph is going to go up to +5, and the minimum is -1. So this range is in between -1 and 5.